We are going to practice finding definite integrals by graphing here. I have given my students through Schoology this worksheet that I want them to actually do ahead of time, because since we're practicing, you should already know this. So why don't you pause it right now if you need to get these questions written down, because I'm about to show you some solutions. All right, so the first one, basically what's happening here is we're finding the area under the curve of the function 3, which is a horizontal line. So the area underneath that curve from 2 to 5 should be a 3 by 3 square, and that area is 9. Let's try the second one. This function 3x is a direct variation going through the origin with a slope of 3. And so for this direct variation from 2 to 5, you're going to need to know the outputs. At 2, 2 times 3 of course is 6, and at 5, 3 times 5 is 15. So this became a trapezoid. Area is 1/2 base 1 plus base 2 times height. So that was 31.5. The third one I hope you remembered was the picture of a half circle. So once you got the half circle, you're noticing from 0 to 5, you're really only finding 1/4 of a full circle. So that formula, 25/4 pi, is an exact answer. You could always round by plugging in 3.14. Now, number 4, you can see we have a function that's negative 3x. So the outputs do create a shaded region under the x-axis. So it's really the same area as number 2, but its answer, you'll notice, for the integration is a negative 31.5. Then, of course, we have our absolute value function right here. Let me just, at this point, move it up for you. And so, for the absolute value function, I see 2 small triangles and I see 1 trapezoid. So the work does show here 2 little triangles and 1 trapezoid. All right, now moving on to just practicing one last time our Riemann sums before we really move into shortcuts. I basically want to talk about the right hand Riemann sum, which, remember, right hands means you are dropping the first data height. So basically what we have going on here is x squared. So x squared is actually a curve. So the area under the curve you can almost make into little trapezoids if you want, but a lot of times in a Calc 101 program they will make it so that you have to find the average of a right and a left-hand Riemann sum. You will notice I asked from 2 to 6. So because I asked from 2 to 6, when we wanted 2 subintervals, we are looking, you can see obviously that it's 2 rectangles with a delta of 2. And the minute I want 4 rectangles, I need to change the delta to go by ones. So this is our visual for it, and I have tried to show you without pictures how I did it. But sometimes the picture actually does make it very clear. Okay? So basically you can see I had to first create an XY chart, and I opted to go by ones. I mean, I could have even gone by halves if I needed to be even more accurate. Next, we're going to talk about how to use a shortcut called the fundamental theorem of calculus. But basically, you'll notice that the area under these 2 curves is 104. The area of these 2 rectangles is 104, and the area of these 4 rectangles is 86. So this is less overreacting. So basically, this would be a better estimation. And so what I want to really do now that we've practiced graphing to find definite integrals, I really want to start using our shortcuts.